Today we're going to talk about solving systems through a method called substitution. So in the previous section we talked about solving systems by graphing, which means we had to graph both equations on the same coordinate plane and look for the intersection point. But as you can imagine, there's times that we're going to cross at some weird numbers in between the grids and not only be able to get the answer. And then we're going to have to kind of guess, and we're going to have to make things a little bit more difficult. So obviously if you have a graphing calculator, that's not a problem, and you can certainly find the exact answer because the graphing calculator will do the work. But we also want to look at some different methods. So the substitution method is next. So here I've already kind of put the first step in. So to solve the substitution, you're going to solve one of the equations for one of the variables. And we're going to talk about what each of these steps means in a moment. Basically what you're going to do is take one of the equations, whichever one you think is easiest, and solve it for one of the variables, and everything else is on the other side. Second step, we're going to substitute the expression that we've solved for in the first part into the other equation. So now we're going to get the other equation involved, and then we're going to solve for the one variable we have left over. And we'll see how this works in a second, but basically what you're going to do is in the first equation you solve for one of the variables. Then you're going to substitute everything else, which is from the other side, into the second equation. So you're kind of mixing them now together, but you should only have one variable at this point, and then we can solve. Step 3 basically says to plug the variable into the first equation to solve for the second variable. And maybe one of the more important things we keep mentioning, but it is extremely important, is to check. Once you think you have the answer, you have to check it to make sure that it is correct. So let's just see what one of these looks like. Having the steps is great, but we need to make sure that we know what to do with this. If I come over here, our steps, again, were solve one of the equations for one of the variables, substitute the expression from that first one into the other equation, and again the other equation, and solve for the variable. Step 3 is to plug the variable back into the first equation to solve for the second variable that you don't have, and then always we check. So here is one in action, and we'll see how these steps work. So in this first example, we already have a one equation up top that is already solved for a variable. It's already solved for y's. So we don't really have any work to do except to plug it in. So what I'm going to do is I'm going to take this expression on the right hand side, 2x minus 4, and where I see a y in the second equation, I'm going to plug it in for that. And this is what this would look like. So 7x minus 2 equals 5 is what's there. But what I'm going to do is where I see the y, I'm going to take the 2x minus 4 from above and replace the y with that number. That's the substitution part of this method. Then I'm just going to follow our regular problem solving, but notice now we only have x's in our equation and we don't have x's and y's. So very first step is going to be to take care of our distributive property. So we get 7x minus 4x negative 2 times negative 4 is a plus 8 equals 5. I can combine x's with x's to get 3x plus 8 equals 5. With my two-step SADMAP equations, subtract 8 first, I get 3x equals negative 3. And then when I divide by 3, I get x equals negative 1. So that is the second step. So from here, I need a coordinate. I can't just do x, I need x and y. So what I have to do is I have to now go back and find the y. So now I can go back up top and I can pick either equation. Well, I'm going to go with the first equation. So we just worked on the second equation, so I go back to the first equation. We're going to take the y equals 2x minus 4, and now I'm going to plug in what x equals, which we just determined was negative 1, and now I only have y's to solve for. So if I solve this for y's, I get negative 2 minus 4 is a negative 6. That would tell me my solution is negative 1, negative 6. Now again, we really should check this to make sure that this works, because just getting those two numbers is really not good enough. And I'm just going to do a check a little bit different than we've done it so far, just to kind of save some time here. So back up top, if I plug in a -6 for the y here, I want to come over to this side and I would say 2 times the -1 is -2. -2 minus 4 is -6. So it works on the first one. Going to the second one, if I do 7 times -1, I get -7. -2 times -6 is a positive 12. -7 plus 12 is 5, so they do check. I don't really want you to do that all the time, but that is one way to kind of check it. As long as you are checking it to verify 100% that that is the answer, that gives us a good shot. So here we have another example. I'm just kind of writing this one in. It's not on your sheet, but I do want to kind of do this one as well. So here we have another system. So looking at this one, we don't already have one ready to go. So here's where you can make the call. I personally am going to see this first one and say, I think it's a little bit easier to rewrite that one. Basically, to solve that one, I'm just going to take the 4y's and subtract it from both sides. And to do that, I'm going to get a x equals 14 minus 4y. So my first step here is to get one of them isolated for one variable. Now, I certainly could have solved that equation for y's. I could have solved the other one for x's or y's, but that seemed to be the easiest one to get to. I wanted to show you this one just so that you could see that sometimes we have to do a little bit of work, and sometimes we don't have one that's ready just to do, like the first example. So at this point, what I need to do is I'm going to take that first equation that we've rewritten, and we're going to plug it in where we see in the second equation. I'll keep it in blue, where I see x's this time. So 14 minus 4y's. And then I finish, this time my equation has y's. So again, then I'm going to follow through with my problem solving to get to what y equals. My first step is going to do 3 times 14, which is 42. I do 3 times the -4y, which is -12y. Then I have plus 7y's equals 22. I have y's that can be added with other y's. -12y plus 7y is -5y's equals 22. I'm trying to get y by itself, so now I'm going to subtract 42, and notice I'm not adding 42. The sign in front is positive, so I subtract 42. By subtracting 42, also notice that we're keeping the -5y's after the 42 is gone. 22 minus 42 is -20. To undo times -5, I divide by -5. Y equals 4. So that's the y value, but we need the x to go with that. So then I'm going to come back up. We've just been working in the 3x plus 7y equals 22. Now I've got to go back into the other equation and now plug in y's equal 4. So I go back to my other equation. I'm going to plug in the 4 where the y's were. And notice I also went back to the original equation. X plus 4 times 4 is 16 equals 14. I would subtract 16. X equals -2. Now, we did them in opposite order. Usually x's are the first thing we seem to deal with. Just make sure that when you give your solution, you put the x first, even though we found it second, and it's -2, 4. Okay, and here we have another real-life application. This time, again, we're getting their equations kind of set up for us, but we want to get good at this eventually. So in this problem, we have way too much information for 2 equations. I want you to notice the first equation. We're talking about the turkey burgers and the veggie burgers. The first equation is referring here to the number of burgers. We have some number of turkey burgers plus some number of veggie burgers would tell us how many we have. The second one is the cost of each turkey burger times the number of burgers would tell us how much our cost for all the turkey burgers were. Cost per veggie burger times the number of veggie burgers would tell us how much it costs for the veggie burgers in total, and then those put together gives us a total cost. So then we want to kind of write those equations out. So basically what we have from what we see up above is that we buy a total of 50 turkey and veggie burgers. So that's going to refer to this first equation. So we're going to get x plus y equals 50. We don't know how many of each, but we know there's 50 in total. The second equation that we're looking at is that we bought a total cost of $90. We pay $2 per turkey burger. We don't know how many turkey burgers there are, so it's 2x. And we paid $1.50 for the veggie burgers, and again, we don't know how many of those there are, but we know that our cost in total was the 90. So here's our two equations. So what I'm going to do is I'm going to rewrite the first equation so that it gives us, we're going to solve it for x's. So to rewrite it, I would subtract y from both sides. So x equals 50 minus y. Okay, and then we're going to join it with 2x plus 1.5y equals 90. Okay, so again, we're going to plug in, give us a little more room here now. I'm going to plug in 2. We're going to replace the x with 50 minus y plus 1.5y equals 90. Now we're going to solve for y's because I have a bunch of y's there. 50 times 2 is 100. 2 times negative y is negative 2y's. That'll break up the group with the distributive property. Plus 1.5y equals 90. I can combine y's. Negative 2y plus 1.5y is negative 0.5 y's. And I have 100 over here. We are trying to solve for y. So the first thing I need to do is subtract 100. Again, the sign that's in front of that 100, we don't see it, but we know that it's a positive. When I do that, I get negative 0.5 y's equals negative 10. Now when I divide by negative 0.5 to get y by itself, we're going to get a nice positive number on the right-hand side. Y equals negative 10 divided by negative 1/2. Remember, that means to multiply by 2. We get 20. And again, this is not all of our answer. So what I want to do next is go back into the x plus y equals 50 equation, since we were just working in the other equation, and replace the y this time with the 20, because that's what we just determined. Now I can just subtract 20 from both sides. X equals 30. So now I just got to figure out what does that really mean. So basically what that is telling us is our x values were referring to the turkey burgers. So we have 30 turkey. And the y values were referring to the veggie burgers. We have 20 veggie. So that is solving with the substitution method. This is a method that will require you to be careful on your steps, careful on your work, make sure you don't kind of get messy on things, and it'll be important to practice, practice, practice to get good at this one. Solving systems by substitution is a good way to solve them, but it does take some work and some determination.